Hello, everybody. This is yet another Evernym demo showing the work we've accomplished in the Hyperledger and Sovrin communities. Today is, November 21st? It's a Thursday, and the team's been making good progress on various things. We've rolled out PBFT view change, the major view change enhancements in the October release, and it got put on the Sovrin Network this month in November. And we knew when we rolled it out that there were some known issues that we needed to work on, some additional cleanup. So we haven't worked on new features on the Indy Node side so much as we worked on polish and bug fixing and general, making sure everything's stable and performance testing, things like that. So most of what we're going to discuss is along the lines of how those fixes have gone. On the SDK side, we've been really focused on adding Aries compatibility to Evernym's libVCX library that we contribute to the Indy SDK. So we're excited about that. We're trying to get it ready for the demo. There's a Sovrin Connect-a-thon the first week of December in Provo, Utah at near the office of the Sovrin Foundation. And we're gonna show that compatibility. Unfortunately, the experts who had built it, they're not gonna be able to be here. So I have to figure out how to do that. So they've been trying to make it idiot-proof so that I can do a demo. So I appreciate all the efforts there. So that's what we'll show today. And with that, it looks like, Alex, you're gonna start off discussing some of the node logic improvements.
Yep, thank you. Okay, let me share my screen. Can you see it?
Yep, looks good.
Okay, so I'm going to tell you about one of the improvements related to the newly implemented PBFT change. This is improvement regarding the logic of how the primary is selected. This work is tracked in Indy 20-62, and you can find more description of the issue, of examples of this problem, reason, and design, how it's done there. Now I will just briefly describe what was the problem and what was the solution. So as for the problem, so in the view change protocol, in the PBFT-like view change protocol, it is required that primary, the leader, is selected at the very beginning of a start of view change procedure. So we start a view change procedure on all the nodes, then the first thing that we do is we select primary, and only then we expect to do all other view change related logic. Primary selection, it's done in round robin, and the round robin is done against a registry of current nodes, the list of current nodes. And the specific of plenum that this list of nodes is kind of dynamic information, because we have a special transaction which is called node, which can be used to add and remove nodes, so that the current state of how many nodes are in the pool is dynamic information, because it's actually dependent on the ledger state and on the uncommitted ledger state. When view change starts, it's not guaranteed that all the nodes are equal, has equal state. So if there is a node transaction in flight, then some nodes may have already ordered this transaction and updated their node registry, but some nodes may have not seen it, so that they still may use a different node registry. But the node need to use this information at the very beginning of view change to select a new primary. So let's just consider this example that let's assume the pool is on view 3, and there is a node transaction to add a 5th node to the pool. And let's assume that 3 of the nodes, not 1, not 2, not 3, finished ordering and updated their node registry So now on these 3 nodes, the node registry consists of 5 nodes, 1, 2, 3, 4, and 5. But on node 4, for some reasons, it was a bit slower, lagging behind, and it hasn't ordered this transaction yet. So node 4, the node registry consists of just 4 nodes, 1, 2, 3, and 4. So all nodes start the view change, they move to view 4, and they start selection of primary. So as I said, it's just a round robin. So the first 3 nodes do a round robin for view number 4 against nodes from 1 to 5. And you can see the 5th entry in this list is node 5. So they select node 5 as a primary. But node 4, it also selects the 5th entry. It's 5th for view number 4 because view starts from 0. And you can see that it's 1, 2, 3, 4, 5. So we have node 1. Node 4 selected a different primary. The problem here that the view change protocol requires that view change protocol actually finishes when a node receives a valid, a correct new view message from a new primary, from a new leader. And as you can see, node 4 will not be able to finish the view change because it will not, it may receive a new view from the node 5, which is a primary for all other nodes, but it will not recognize it as a primary because this node thinks that node 1 is still is expected to be a new primary. So this is a problem. We implemented a number of integration tests reproducing this problem so that we delay some commits or prepares, making the node slow. We add the node 5, like in the diagram that I showed. We trigger the view change, and we're making sure that view change is finished all the nodes. There are multiple variants of these tests where we delay, for example, commits on 2 nodes, or we delay prepare or commit on 1 node. So while the test is executing, let's move to solution. So the solution is kind of obvious. We need to make sure that all nodes select the same primary at the beginning of view change, regardless of the current node registry, view number, and what node transactions are in flight. And in order to do this, we chose the following algorithms. So we store the current node registry as in audit ledger, and we use the node registry as it was at the beginning of last view for this round robin. And also it implies that we need to do view change on every change of node registry length, which is actually not so frequent operation. And with this change, if you still consider the same example, if we had view 3 at the beginning of view 3, all nodes had the same registry, although at the end of view number 3, there is a different node registry. At the beginning of view change to view 4, they all select the same primary since they use the same list. So this is a fix. And so what are the benefits of this solution? Well, first of all, the issue is fixed. Also, the logic of primary selection becomes more deterministic, which simplifies the primary selector logic. It just becomes a quite trivial round robin. And also it allows to simplify the code, node registry processing code. It becomes more modular, less coupling. So for example, now we can support node transaction in simulation tests. And also we can get rid of some legacy code, for example, pool manager class, and replace it by a more simple version, more modular and without unnecessary dependencies. So you can see the test passed, and yeah, we also have system tests that also pass now. Any questions?
That was really nice explanation, Alex. Thank you. And I'll be, I have your slides. I'll be putting a link to those slides in the notes to the video for anybody who's interested. I expect in the future when people dig through the logic, it'll help them a lot. So excellent. Renata's going to show us through another of the tricky problems we found on the Sovrin networks.
Hello, can you see my screen?
Yep, and we can hear you too.
So, a few weeks ago, we found similar problem on a couple of pools. Adding a new node didn't work because in a state restoring from a ledger, it didn't match the same of other nodes. In version 1.9 0.1, the following record was added to the state containing of ledger signature field. Due to the new updates, the date format in a state has changed, which is quite normal for system, but states should be same on all nodes. There were several possible solutions. First, send a auth rule transaction to update the value for this key in the state. This would solve the problem quickly, but records in the audit ledger would become inconsistent. In addition, it was necessary to find a common solution for such situations, since they could well happen in the future. So, the idea of versionet adding transactions to the state come up. Thus, each transaction will be restored in the way that was used for its version. If a transaction was added to the state of node 1 using method A, then after update the pool and joining a new node 2, for example, transaction 1 will also be entered into the state using method A. How do we know the version of a transaction in a restoring state? If you look at the transactions in the config ledger, they will look like this. Planning an upgrade of the pool to a new version, confirmation from each node that the version of the code is updated. And here we can determine that if the n-f nodes send a confirmation, then the pool changed the version of the transaction record. Using the strategy pattern allows to use the necessary transaction handler to write to the state. The handler is selected based on the version in which the transaction was ordered. So, to test a new feature, the following tests were written. Changes are currently being checked using system tests. Thank you. Any question?
I appreciate that, Renata, and all the work that you and the rest of the team did to make sure the Sovrin network's stable with all these changes to the system. It's really good. So thank you. Now, Artem's going to talk to us about the improvements to libVCX.
Hello, everyone. So we are working on making VCX compatible with Aries protocols. Our work for a couple next weeks will mostly devoted to extending test coverage of VCX. We added multiple integration tests and unit tests for Aries models. Also, we did one more steps on the way to Aries compatibility. This step is integration with Aries Test Suite repository. In Hyperledger Aries RFC, there is an RFC related to Test Suite. This RFC describes main goals of which library should provide to ensure the two different agents are compatible with each other without communication. So there is a tool which can be run against any of agent implementation, and this tool can tell which protocols are supported by these agents, which are not, and which can be improved. There is a repository in Hyperledger GitHub. This simple Python project which runs a set of Aries protocols, set of tests devoted to Aries protocols against HTTP. I'd like to say that this protocol, this library in the very beginning state, it's actually improves now, but even now it can be really useful to ensure that your library is compatible with Aries. Now, it contains multiple tests devoted to connection protocol and basic messages. So we achieved a compatibility with it. There are in the current state, there are multiple tests which should be run manually. So it requires user input from agent side. But also we work on making it automatic. So now I would like to show a simple demo. I'm not in the master branch now. I'm on my local changes in which I did some kind of automatic tests. These tests use HTTP to send commands to our server, which use libVCX under the hood. So now I'm run test suite. There is a pretty good README for it. There is multiple settings which allows us to specify the set of tests which will be running. For this test, which demo I will show, I will use 4 different tests. 2 of them automatic testing is the server library can be invite on VT for connection, and 2 of them are manually. Let's run it. So now it started the first test, which checks if agent can be invited. Yeah, if we look on our server, this happens different events, and now the second test is started. This test different is the server can be in VT. Well, 2 tests pass. The first one test is manual, and it requires putting an invitation. Now I started our usual VCX demo, which shows how it can be used for invite connection. Now it will generate invite, and I'll use this invite in our test suite. It takes some time because of some preparation. Well, one more minute. Yeah, invitation was generated. Put it here. Yeah, it went. The third test passed also, and the last one we use invite site. It also requires manual input. Yeah, so here we can see the report. This report shows us which test we ran. In our we ran 4 different tests. All of them are passed to automation to manual. There are also multiple different tests devoted to connection protocol. This test checks different scenarios on sending different messages from different states. So that's it from my side. We are still working on a protocol test suite improvements, and it should probably will be used soon. Really helpful. Thank you.
Fantastic. It's great to see that. That's the most. We added a bunch of additional tests and framework for that. Makes it much more useful. That's going to be great to show off at the Connectathon. Now, coming up, we've completed most of the new features we've been excited about for the last little while. So the next sprint, we've been so focused on these core features in 2019. In the Indy ledger, we've added the audit ledger, we've added auth rules, we've added we've refactored plugin handlers, we've changed view change. We've done significant changes to Plenum to make it a really robust. At this point, I'm pretty sure Plenum's the largest deployed RBFT network, is Sovrin anywhere, and it's performing really well. So that's been exciting. Now that means we've put off a lot of bug fixing in order to do these larger changes. So we're going to focus on that the next little while. We've got a bunch of those teed up. One batch of bugs we've been nervous about is the replicas in Plenum. The way the RBFT replicas are handled have a number of deficiencies. Our current proposal is to remove them. We probably won't get to that done in the next 2 weeks, but we'd like to start that effort. We're still doing some analysis to see if repairing them makes sense. So that's the current status of that conversation we're having. So on the Indy Node side, we'll probably be doing bug fixing for the next 6 weeks and get in a new feature development in January after we have our holiday break. On the Indy SDK side, now that we've got the libVCX and Test Suite stuff largely working for our Connectathon demo, we do want to get that released. We're going to mark some portions of Indy SDK that have moved to Aries at this point. We're going to deprecate. So we want to make that clear. Some of the documentation is deprecated. And then we need to we have a whole chunk of bugs. Our main focus the next couple of weeks is still going to be improving the test suites and improving the Aries support in libVCX. That's the bulk of our efforts, but we should have some time to do additional bug fixes as well after we get the release out. So that's the plan for the next couple of weeks from the Evernym team. If you have any questions, please reach out. We hang out at chat.hyperledger.org. That's a Rocket Chat instance. We also check out Stack Overflow on occasion and answer questions there. And we love to interact with people who are using our software. We, of course, love pull requests. We try to keep up on the various contributions people make. If you submit a pull request and want more feedback on it, we're happy to schedule a call to have that discussion. Just let us know. So with that, I will we'll end this video. I'll get this posted and we'll put another video on YouTube in about 2 weeks. So thank you.